Hello, this is not your chem tutor, and in this video, I will teach you how to solve molarity. Molarity is one of the most common expressions of solution concentration, and it is a term that you will encounter a lot in chemistry. In this video, I included 5 examples so you can practice answering questions involving molarity. Here are the skills you need to answer questions about molarity. Number 1, you must know how to calculate the molar mass or the molecular weight. And number 2, you must know how to do dimensional analysis. I made separate videos about these topics and you can check the links on the description box. Let's proceed to the formula. There are 2 formulas you need to take note to answer problems about molarity. The first one would be the formula for molarity, which is equal to moles of solute divided by liters of solution. So the unit for molarity is moles per liter, or this is also known as molar, and the symbol is capital M. So moles per liter and molar are just equivalent. So when you say 1 mole per liter, this is just the same as 1 molar. The second formula would be moles of solute, that is equal to mass of solute divided by the molar mass of solute. Let's try example 1. What is the molarity of the solution if 0.450 moles of NaCl is dissolved in water to make a 3-liter solution? So in this problem, our solute is NaCl and our solvent is water. So always remember that the solute is the one being dissolved in the solvent. The problem is asking for molarity, so we will use this formula above. Molarity is equal to the moles of solute, and we are given 0.450 moles of NaCl. So you put 0.450 moles on the numerator, and on the denominator, you put liters of solution. And we are given 3 liters of solution. So you put 3.00 liters on the denominator. So if you solve this in your calculator, 0.450 divided by 3, this is equal to 0.150 and the unit would be moles per liter. So 0.150 moles per liter or 0.150 molar. Again, remember that moles per liter and molar are just the same thing. So this is the answer to the question. Example 2, how many moles of solute is dissolved in a 500 ml of 2.50 molar aqueous solution of glucose? So in this problem, glucose is our solute and water is our solvent. So when you encounter this word aqueous, this means the solvent is water. So we still use this formula above. We are given the molarity, 2.50 molar. So that's 2.50 moles per liter equal to, we are not given the moles of solute. So just write moles of solute divided by the liters of solution. We are given 500 ml of solution. The unit is still in ml, and what we need is liters. So we need to convert 500 ml to liters using dimensional analysis. So 500 ml, we know that 1 liter is equivalent to 1000 ml. So ml will cancel, and this is equal to 0.500 liters. So we put 0.500 liters. To solve for the moles of solute, you multiply both sides of the equation by 0.500 liters. So 0.500 liters will cancel on the right side, and what remains on the right side is moles of solute. And on the left side, you have 0.500 liters times 2.50 moles per liter. So liters will cancel, and the remaining unit is moles. So 0.500 times 2.50, that is equal to 1.25, and the unit is moles. So the answer to this question is 1.25 moles. Example 3, what is the volume in liters of a 0.300 molar aqueous sodium hydroxide solution containing 4.5 millimoles of sodium hydroxide? So NaOH, or sodium hydroxide, is our solute, and our solvent is water, since the solution is aqueous. So we will still use this formula. We are given the molarity, 0.300 molar. So 0.300 moles per liter equal to, we are given the millimoles of solute, 4.5 millimoles. And what we need is moles. So we need to convert 4.5 millimole to moles using dimensional analysis. So 4.5 millimole, 1 mole is equivalent to 1,000 millimole. So millimoles will cancel. So 4.5 times 1 divided by 1,000, that is 0.0045 moles. So you put 0.0045 moles on the numerator. And on the denominator, liters of solution. We are not given the liters of solution, so just write liters of solution. If you want to solve for the liters of solution, you multiply both sides of the equation by the liters of solution. So liters of solution will cancel on the right side, and what remains on the right side is 0.0045 moles. And on the left side, you have liters of solution times 0.300 moles per liter. Divide both sides of the equation by 0.300 moles per liter. So 0.300 moles per liter will cancel on the left side, and what remains on the left side is liters of solution. And on the right side, we have 0.0045 moles divided by 0.300 moles per liter. So moles will cancel. The remaining unit is liters. So 0.0045 divided by 0.3, this is equal to 0.015 liters. So the answer to this question is 0.015 liters. Example 4, what is the molarity of a solution made by dissolving 11 grams of sucrose in water to a final volume of 0.05 liters? So sucrose is our solute and water is our solvent. The first step to answer this question is to solve for the moles of solute. So our solute is sucrose. So moles of sucrose is equal to mass of sucrose, that's 11.0 grams, divided by the molar mass of sucrose. We are given the molecular weight or the molar mass of sucrose, which is 342.296 grams per mole. If in case the molar mass or molecular weight is not given, you need to compute it on your own. So grams will cancel and the remaining unit is moles. So 11 divided by 342.296, this is equal to 0.0321 moles of sucrose. Now that we have the moles of sucrose, we can now compute the molarity using this formula. So molarity is equal to the moles of solute, 0.0321 moles, divided by the liters of solution. We are given 0.0500 liters. And this is equal to 0.642, and the unit is moles per liter, or 0.642 molar. And this is the answer to the question. Example 5, what mass in grams of glucose must be dissolved in water to make 100 ml of 1.40 molar solution? So glucose is our solute and water is our solvent. We will use this formula first. We are given the molarity of the solution, 1.40 moles per liter. This is equal to, we are not given the moles of solute, so just write moles of solute, divided by liters of solution. We are given 100 ml, so we need to convert this first to liters using dimensional analysis. So 100 ml, 1 liter is equivalent to 1000 ml. ml will cancel, and this is equal to 0.100 liters. So you put 0.100 liters on the denominator. To solve for the moles of solute, multiply both sides by 0.100 liters. So 0.100 liters will cancel on the right side, and what remains on the right side is moles of solute. And on the left side, you have 0.100 liters times 1.40 moles per liter. So liters will cancel, and the remaining unit is moles. So 0.100 times 1.40, that is equal to 0.14 moles. So now we have the moles of solute, 0.14 moles. Then we will be using this equation. So we already solved the moles of solute, 0.14 moles. That is equal to the mass of solute, which is not given in the problem. So just write mass of solute divided by the molar mass of solute, which is 180.156 grams per mole. So put 180.156 grams per mole. To solve for the mass of solute, you multiply both sides of the equation by 180.156 grams per mole. So on the right side, 180.156 grams per mole will cancel. And what remains on the right side is the mass of solute. And on the left side, you have 180.156 grams per mole times 0.14 moles. So moles will cancel, and the remaining unit is grams. So 180.156 times 0.14, this is approximately equal to 25.2, and the unit is grams. So the answer to this question is 25.2 grams.